And we are live. So I will take off. Uh, in like another 2 3 minutes, you can start the session, Yashab. Okay.
Yes, just finishing the setup.
Okay. If you want to share your screen or something, go ahead and do it.
Yep.
Oh, I like this profile picture.
Hello.
Yeah, we can hear you.
Yes. 1 minute, please.
Uh, Yashab, are you there?
Yeah. I'm-
Can you tell that my screen is sharing?
Yeah.
If my screen is sharing,
I can see your screen, but this screen is like your Google Chat window.
Yep, that's what I know.
so well, hello. My name is Yashab Alam, and I'm a AI and ML developer. So we are starting to how to train an AI model. Basically, for training an AI model, we choose a base model like Llama, Google Gemini, and any other model from Hugging Face. Hugging Face is a revolutionary website where different types of model are there, like that. If we check here, like server security model, so like someone has trained the server security model Lily by using the Hugging Face. We can actually download the base model and train the base model in our dataset. We are using for training purpose Google Colab. Like like here. So I'm training my model as a name is Louis. Tiny LLM merge. Basically, this model do that. Train on different PDFs of cybersecurity, and I'm making the Louis LLM for our cybersecurity research personals. So I have shared that code. If we run that code,
So, yes, sir. One question on the base model selection itself, right? Before you get started, how did you choose your base model? And once
basically, yeah, there are several criteria like on cybersecurity. I have just go to Hacking Face and choose the if you are interested in any other model like L
yeah, I
Llama,
would like to see some benchmarking. What kind of benchmark you looked into, and
yeah,
how
like
did you get
yeah,
started?
yeah, like suppose L Llama Force Scout. This model is basically for corporate identifier. Yep. There you need to analyze the needs of what AI model should be you choose for. Like suppose I'm a cybersecurity enthusiast, so I'm training the person, choosing the base model as a cybersecurity. If you are in finance, you choose a generic model will be Google Gemini, ChatGPT, or any other like Facebook Llama. If they are the generic models, but in my case, I am using the Llama was and Lily was as a cybersecurity, and so that cybersecurity trained well.
Uh, so,
Yes, yes, sir. Can you tell me just the use case, like what use case this model gonna solve
no,
in
no, I just say
cybersecurity?
I'm saying in cyber security itself, right? You might have multiple models available on the Hugging Face, correct?
Yeah, yeah.
Okay. So, what kind of benchmark you looked into before choosing this particular one?
Like suppose I'm go to search bar and like you have finance. Like finance.
Uh, Yashab,
Yes,
see,
finance.
that's selecting
Yeah,
model for a domain. Within a domain,
yeah,
there will be multiple models, right?
yeah,
Okay,
yeah,
right? Correct.
yeah.
Once you have a if you have a multiple models, how do you evaluate which one is good to go for you?
Firstly, you can consider any model because we are training the model for ourselves with our data sets. We are using the model for a reference only purpose only.
No, no, you have to look at the model parameters, right? Model size and all,
Yeah,
correct?
yeah,
Memory footprint, everything, right? So then only we can start at the minimum, right?
yeah.
Ashram, sir, sorry. Go ahead.
Yes, but as a starting, you will I think I suggest you use The llama, a tiny llama, because it is lightweighted and train on a normal PC. Llama and Gemini and GPT model as a starting. But if you are going to an domain, just go Hugging Face because there are no different models. Like in cybersecurity, we have only Lily. In finance, we have finance LLM. If you, I don't recognize any other model.
Sure, please go ahead.
Yeah. So have you? Yeah. 1 minute. I enter the API key.
Yashab, if you are speaking, you're on mute. I'm not able to hear you.
Yeah. So I'm training in that model in cybersecurity books. I have multiple books, and this is the whole code for training a model in through a PDF books. So right now my and second thing, the in the Google Colab there are I'm using the T4 GPU, which is the best train a model. We have many other GPUs as well. Like if you go to runtime and change runtime, so the normal CPU, V28 TPU, T4 GPU. These three are on the free version, but if you subscribe to Google Colab, you get A100 GPU, L4 GPU, V5 E1 TPU, and V6 E1 TPU. The suppose you are training a small model like tiny LLM, which then it is run on T4 GPU. But now right now I am training the big model, so that's why the error is coming. Like if you check, so it says theory out of memory. And second thing, it has the built-in Gemini feature. Like if we explain error, so it can provide the actual edited code. any questions related to that? For tracking system, we are using the weight and biases. Like, like, see, this is my training graph. How I train a global step, and this is a train e push. Yeah. So any question related to that?
अलग अलग रहे इसी वजह ज्यादा आगे नहीं होते हमारा समझ आ रही है
Yes, sir. Can I ask one
Yeah.
general question?
Yeah, yeah, sure.
How?
इंडस्ट्रियल डाल दुकान डाल दिया जाता है
What is the purpose? Like, what problem we are solving here with this model? Like,
Like I'm training the cybersecurity model. I'm basically making the Linux environment working intelligence system, which do the SOC analysis. Like it is a cybersecurity tech, like SOC analysis, IDS, intrusion detection system, log analysis. Yeah. So in my Lewis LLM, they it is trained on that model data sets. It can prevent the intrusions or any misbehave activity through the servers or the internet things in a particular company or as a organization.
so,
Yep.
so, so this system is this model will be used as a like a chatbot, or like it would be like
No. In a chatbot is a other thing. It is used as a core function of the app. Like it is the brain of the app. We can also use it for chatbots things. Like basically, like if I organization use SOC analysis, the organization want to check the SOC analysis on monitoring uh, and on a real time. Yeah. So they go through the Lewis and check the option, turn on the SOC analysis option, and the uh, and at the IP of their own organization, the SOC analysis starting. Through the SOC analysis, they can monitor how much data is coming and from where data is coming, and how much data is going and where from where data is going.
I see.
Yeah.
Yashab, just say you trained this model, right? How do you know this is better than the base model you selected? How are you evaluating the performance of this model?
I'm evaluating the performance of this model because as I have set the criterias. Like suppose that for the testing purpose, I just give a malicious data packet. Yeah, I am using the tiny element model also, but the tiny element model doesn't recognize any malicious data packet. But my Lewis can detect it.
No, but okay, that's something you tested on a one use
Yeah, yeah,
random,
yeah,
right? But
yeah.
if I have to quantify it, right? How are you quantifying it? So this is the one use case where your model might be doing better. But if I have to generalize it, if I have to take a call, okay, why you I have to go with your model or other base model? How do I do it? Because I can't generate one test case, right? You must have some benchmarking. Okay, these are the 100 test cases, and out of these 100, these are public available benchmarking. When you
Yeah,
evaluate on this
yeah, yeah,
publicly
yeah,
available
yeah,
test
yeah,
case.
yeah. Yeah. So for that, I am training Louis LLM around the 1 TB data which are published through different universities in cybersecurity. No any model can do right now present in the environment.
No, no, I'm not asking about that, Yashab. I'm asking
Yeah,
we are done with the modeling part. Okay, fine,
yeah,
right?
yeah.
Yeah, that's same what Pratik is asking, right? What's the performance gain you are getting over a base model?
Like for performance of the differentiate from the base model,
I
we
mean, like
are
question you like whether you did any performance benchmarking or not, like, or you are just training this data, this model.
basically right now I'm just training the data. I have trained the data, and for testing I just do the send the one malicious packet, and it was able to detect them.
Ankit, like now because you asked this question, now you have to help him to set up his benchmark. You can guide.
Hello,
Hello.
am I audible?
Yeah, yeah, sure.
Hi, Yashab. There is something called as the F1 metrics, which is used to determine how the your model is performing in the
Yeah, yeah,
term machine learning.
yeah.
So, what's
Basic.
the F1 metrics of this
So
model?
yeah. So basically, I am just not training the model, not actually evaluating it. After the model is trained, like I have to train on 1 TB of data, and I have just started on the books and pdm for the basic knowledge, and the university research papers, you know. So once we have uh, trained the model fully, we can conduct the text.
Okay, okay, sure.
Yeah,
And one other thing, there is something called as Hack GPT. How
yeah,
this is different from the Hack GPT? As far
yeah,
as
yeah,
I know, that Hack GPT is currently being used widely for all of the thing like talk and log analysis and all kind
yeah,
of those penetration testing and all. So
yeah.
how Lewis is going to be different from that?
like like I have said, the raw data. uh, I the difference between is raw data, because the hack GPT or any other if you want to train your own model, cybersecurity model, you have to analyze the raw data, and which is a time consuming process, because the data enough there is no enough raw data. We have process data like exploit DB and CVE, but we are talking about the raw data. Like
Okay,
suppose like
yeah.
example like suppose if I just go to my training app, give them a malicious code, and it will generate a response. I capture the response, and then on the basis of response I train it again.
Okay, okay. But I think there are several other models which provide plugins like which you can connect to your own logs. Like in the term of log analysis,
Yeah,
you
yeah.
can set up your logs and they analyze the log and provide you a detailed report and so on. And their F1 metrics and all the performances are so good. So how you are gonna compete with them?
So for the competition we are using a USP. Like I'm not making only the brain part, I'm making the whole application of it. Yeah. So in that occasion, we are trying to counter these the most common attack, ransomware attack. In the mentorship of Sandeep Shukla sir from Kanpur IIT of cybersecurity, I am trying to build a system in which the user can avoid the ransomwares,
Okay.
because there is no anything that counter the ransomware. I have also writing the research paper of it. Soon I will send it on the WhatsApp.
Okay. Okay.
So,
One
so
more thing
how are you
is there,
training the model?
since you
One by one, please.
So my query is how are you training the model? Because I have seen that you have a lot of PDFs and research papers, right, using which you
Yeah,
are training the model. So,
I don't I have basically in the training part, as a starting I have started for the basic knowledge from PDFs, books, research paper, but I have explored database also.
so from PDF, how you are putting that data into your model? Can you explain that part?
Yeah. For that I have written the Python code, in which Python code it extract the text form
Okay.
from PDM and save into the txt file and then train it. Like for training model, we can do not directly train with the PDF. We can train with the CSV file, txt file, and one JSON file.
Okay. What is that in that JSON? The complete text of that PDF?
Yeah. For the basic knowledge, it will be completely text form.
Okay. So it is not instruction based or the question answer based. Means we are dumping the whole text of the PDF file into this model.
Yeah, for the wider range of and we are using the base model for question answering also.
So how are we creating those question and answer?
Like suppose I have to set the parameters. I will set the code. I have set the parameters. I have set the parameters. Like suppose the written text about nmap. The base model check its nmap and all about the parameters and the commands of it, and form the different types of question answers and train from that.
Okay, so those question and answer are you are getting dynamically or you are taking at the runtime or you are taking manually.
No, it automatically generate it and train on that model. Like suppose I have a set of PDF. For
Hmm.
that, a high level T4 GPU, I have to train about 5 hours, because from a single string it can form hundreds of questions.
Yes. So can you show us the code where you are doing
Yeah,
that?
yeah. I have sent it previously. I am giving you to in the WhatsApp group. Like this is the code. I'm just copy paste it.
Yashab, can we go through the parameters of the fine tuning ones, if possible? What are the parameter which you have set while fine tuning, and how did you choose them, or what's the range?
Like I am collecting the books from 2020s and a research paper from 2020.
No. So not so there are parameters like temperature and all, right? When you do the
Yeah,
fine tuning of the model, I'm
yeah,
interested
yeah,
in that part.
yeah.
There are
So
multiple.
like example, like there is a function called tokenizer function. Check it.
Yeah, that's for the tokenization, right? I
Yeah.
understand that part. I'm talking about specifically fine tuning where you are passing all this information to the base model, and
Yeah, one. I send the code here and soon send the code in WhatsApp group. So like if you talk about parameter, here's the parameter function. Like we are using the Python torch library for it.
So you have to set the values for the parameter, right? Okay.
Yeah,
That's what
yeah.
I'm asking. How are you doing that?
Like for setting, we have this.
And let's move away from the text processing part. Can you go to the fine tuning part itself, Yashab, in the code?
Yeah, yeah.
Code.
I will definitely show the training part. Like this is there, but right now I am not connected to the main account. That is it is running
No, no,
on
no. In the
T4.
code itself. In the code itself, right?
Yeah,
I'm okay. I'm not looking for
yeah,
it anymore.
yeah. So if you this big,
So I am interested in chaining arguments. You say tokenizer, I understand, but chaining arguments.
like
Yes.
for
Yeah.
define
Yeah.
training arguments,
So how
like
did you
training
set the
argument.
batch size, accumulation step, learning rate? What kind
Yeah,
of part you did the learning on the learning rate, right?
yeah,
That's
yeah. Because I have choose the 2E4. There are many learning rate also because I am training the model in the previously trained merge model. Like if you check here, I have Lewis 10 LLM merge model. So that's why I'm training the training algorithm that's 2E4. But if you are using the main base model, you can change it like 1E4 or 3E4. For 2, 6 and 8 we have use only for our personally set models. And second, if you have a strategy, I've defined the no because I'm running the out of T4 GPU. If you change it as a safe strategy is equal to yes, then the GPU takes more time to train a model and more memory to train a model. Second, we have a logging directories. Like suppose a step is missed in the training model. So the all these steps are saved in the .log file. Any other questions?
no. I'm fine. Good. Thanks.
Like, like. So sorry for the inconvenience to don't show that the model is training because I am not on the main account and my memory is run out and it will restore in 24 hours. Like on the free version, if your memory is go through, it will take time to restore in 24 hours.
So, yes, sir. Like, could you please tell me more about now about your company overall? Like, how what you gonna sell to that? What product you are making? And
Yeah. So I am making my cyber security company. We are selling the Lewis LLM for the other use. So in it will be the body of the Lewis LLM. Yeah. Yeah. And so other we are also selling the courses of Lewis, like if the how the user can interact with Lewis
so,
because in, in Lewis there are many different commands. Like on it will be firstly I will making through the tooling on Linux system servers. So that the error coming out is generally in the Lewis. So how the user can interact with errors and debug it.
So you guys are like a more like a model provider. You are not like a something like a ready-made application which we
No,
can use.
no, we are also building the ready-made application named Lewis also. Its name is Lewis, Linux Environment Working Intelligence System. It is the application in which the Lewis LLM or a different model can also be used. It has the option to select the model.
Do you have some kind of a little demo like one or something working thing like how you are? So that gonna gives like more clear picture to us. Okay, yeah. Anything that talk okay how the user gonna like end user will use that Lewis application, one slide or something. No.
Basically, so, today I don't show them because the I it has the uncompleted form. But I can share the screenshots. Yeah, I can share the screenshots in the group.
Okay, okay,
Uh,
that's good.
yeah, like I'm sharing. I have shared the screenshot on the group.
I see. Yeah.
Yeah. For like so you are using the question answer chat bot for chat assistant. It is using the Lewis LLM.
Yeah, I'm looking.
Yeah.
Yeah, I'm looking that. Yeah. Now this gives a little idea like overall picture of
Yeah.
your product. Tools, audit paper, chat assistance,
Um,
Basically, yeah.
Go ahead, Kaushik. बॉबी सर और कुछ है क्या एजेंडा में आज? Uh,
I'm not sure if Bobby sir is still here. He said he won't be able to stay on. He started recording.
I think this is my time. So, do you have any other questions for that?
So Yashab, can you share the code also? Whatever code you are running to train the model and few sample files
Yeah,
you have
yeah,
used
yeah. I
on
have
the
I have definitely sent the code and the files folder to the and the research report also that I was used to train in the group.
okay. Share it on WhatsApp. That would be nice.
Yep.
So any other agenda, guys, today?
Uh, Deepak sir, I can quickly cover थोड़ा सा फाइन ट्यूनिंग वाले चैप्टर का पार्ट पैरामीटर वाला जो
महीना रखा तो अकेलो एक
So
हजार
you are
की
sure?
मिल गया
yes sir, can you go on mute please?
Okay, yeah. Yeah, you can cover. Yeah, we have still 15 minutes left, so we
Yeah,
can
you
cover
can.
that.
Yeah, yes, yes, sure. You can cover it that.
So please let me know once my screen is visible.
नहीं वहाँ नहीं थी रमजान के मारे हम लोग रमजान के मारे वहाँ नहीं गए
Okay, so I have not prepared any PPT because I was not planning to take up anything, but थोड़ा सा time है तो I thought we can cover this. So last session में हमने discuss किया था कि how do we choose whether to go with fine tuning or whether to go with prompt engineering, right? Let me zoom a bit for everyone's reference. Okay. So basically, depends upon times and complexity part, right? Ki if we have a lot of time and we have a lot of resources, we can go with obviously fine tuning. But both time and complexity part, time become a complexity be like we don't have a resources. Prompt engineering is best way to tune a model for something quick, right? So I'm not getting into detail of it as of now because we already covered. So what memory bottleneck. This is something we left in the last session, right? Okay. So fine tuning, all right. Why fine tuning should be considered as a last step is simply because of the requirement of the memory here, right? So यहाँ पे we are going to get into memory calculation. So for the any model fine tuning, so we have these challenges. So a model have a number of parameters. Just say we say a LLM model has a 13 billion parameter, right? So when we say for example when we talk about any model, we always talk in terms of parameters. Just say Llama 13B or Llama 6B or 1B. 1B there means number of parameter in the model. Within those parameters, there are two kind of parameters. So one is trainable parameter, one is a Trojan parameter. So Trojan parameter which do not change, so we are not worried about the Trojan one. But number of trainable parameter is what actually contribute to the memory footprint. And then what also comes, how are you representing those parameters? तो इसका मतलब है कि जैसे फॉर एग्जाम्पल 13 billion parameter model, ठीक है? So one parameter can be represented with 1 byte, 2 byte, 3 byte, 4 byte, depending upon how much precision you want in your model in the representation. तो अगर मान लीजिए कि 13 billion parameter and you are representing with 1 byte each parameter, it means that कि आपका you need 13 GB of memory for that particular model. But if you want higher precision, right? आपको 4 byte चाहिए. Basically double precision. 4 byte means 32 bit, right? Which is double precision. So you need 13 into 4 uh, uh, memory in terms of GB. ठीक है? तो more the trainable parameter, higher the memory footprint, and you can reduce memory requirement by fine tuning by reducing the number of trainable parameter. ठीक है? So there's a concept called parameter efficient fine tuning, which is used to fine tune the model. If we are getting into fine tuning, तो उसके लिए what we do is that there's a technical quantization. Quantization में क्या होता है कि you reduce the precision of the model. Just say the example I was talking about, for a model of 13 billion parameter, you are using FP32 means 4 byte per weight of 52 GB for the whole weight. तो अगर आप FP32 यूज कर रहे हो, but just say instead of FP32 you are using FP16, you are going to take only 2 byte because 1 byte means 8 bits, right? So memory needed for model weight decreases to 26 GB. ठीक है? So now inference is typically done using a few bits as possible, right? 16 bit, 8 bit, and even 4 bit. So there are two things. Okay, one is inference and one is training. Training matlab when we are doing the model, when we are building the model. That part. Inference part is referred to the model building ho gaya. Now we are querying the model. Even when we are querying the model is going through the all those steps. Okay? So you might train a model with a higher precision. Just say FP32. But for the inference, all the companies like even ChatGPT or Gemini and all, what they do during the inference time, basically when we are asking a question to GPT or a Gemini, what they are doing is simply, reducing the precision of the model at that point of time for the inference, right? So that their compute cost doesn't go very high. Um, I'm not able to see the screen, but if any,
Hey, Ankur,
yes, sir.
Amardeep here.
Yes.
So, so, so this mixed precision, something is mentioned about mixed precision there. So is it on the same? I mean, the training is going on. This mixed precision can be done at the same time, or it has to be, you know, done differently. Suppose we have two precision type, right? One is you are having a 4 byte and one is 8 byte, right?
Uh-huh.
So that can be done together simultaneously, or it has to be
Yes, sir.
some separate.
It is being done simultaneously, but you are choosing what you want in higher precision and what you want to go in lower precision.
Okay, okay, and as you mentioned just before minutes about the evaluating, right? If this is the precision and you are multiplying that with the, and you are coming out of a number with a number for that memory. So is
Mhm.
there plus add-on for the risk kind of, you just evaluated the exact, volume, but there should be some add-ons as well, right? That risk has to be there, right?
Right, sir. Yeah.
So how that is getting involved into this? How that can be involved? So it is always like plus side we have to evaluate, or it is how
So
we do
I'm
that?
talking about once we are done with the training in the mixed precision, how are we doing the evaluation, sir?
No. Before that, right? You calculated the memory, right? If you have this precision value and you have this much, um, what you say, uh, you come up with the number, right, by multiplication with the weight, right? So that was kind
Uh,
of exact
you're
estimation.
talking about how do we choose FP32 or FP8 or FP16?
No.
Like in
Suppose you
what
have chosen, right? You have
proportion?
chosen, right?
Uh-huh.
And you have such volume, and you multiplied that volume with these bytes, and you come up, okay, this GB memory is kind of uh, benchmark for it, right? That is what you did.
Right. Okay.
Yeah. So that is you knew the volume and you multiplied it, and then you came up with the some number, right?
Correct.
But
Okay.
there may be a risk, right? This exact number may get exhaust or something like that.
Sir, this is something I will cover in
Okay, okay, okay,
next part.
okay,
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 I'm
okay,
just moving towards that. Okay,
okay. Sure.
yeah. Okay, so it's not exact number. There is this is just for the parameter, sir. तो उसके बाद
Okay.
भी you need some space for the gradient. You need some space for the activation function, right? So
Mm-hmm.
usually what they do is they will 52 GB and they will multiply with a factor of 1.2 or 1.3 to take into account the other computation as well.
Okay. Sure. Sorry, I couldn't put my question
Yeah,
uh,
I know.
clear way. Yeah, that's fine.
Okay, ठीक है तो नेक्स्ट थिंग इज बैक प्रोपोगेशन एंड ट्रेनेबल पैरामीटर तो अभी जो भी एक्चुअल में मॉडल की ट्रेनिंग होती है यू इज बीइंग डन अ स्ट्रेटजी कॉल्ड बैक प्रोपोगेशन and then in that there's a concept of trainable parameter so like I was mentioning earlier there are two kind of parameter in the model one is trainable and one is frozen okay so frozen are the one which are kept unchanged we are not changing the frozen one during the fine tuning but the one we are changing during the fine tuning are they need to be updated okay so we are particularly focusing on the trainable parameter parameter, because that's where, because you are not changing, we are not worried about their memory footprint there. So let's go to next page. Yeah, okay. Now we are so as of writing, neural network are typically trained using a mechanism called back propagation. Okay. So with back propagation, each training step consists of two phases. One is forward pass. Okay. So forward pass is nothing but a process of computing the output from the input. Just think of it as simple as कि आपने chat GPT को एक query लिखा, you got the output. So which is forward pass. But backward pass is something which is used during the training. कि एक आपने एक इनपुट दिया, आउटपुट आया, you saw how good the output is or what the error in the output, and you use that error to update the model trainable parameter so that it can do better next time. तो inference time पे केवल forward path matter करता है, but during the training time, backward path is what important to us. So for okay, so इसमें we will go down. So yeah, this is just a description of how the forward backward path works, right? Compare the computed output from the forward path against the expected output, the ground truth. If they are the different, model made a mistake and the parameter needs to be adjusted. Uh, and then compute how much each trainable parameter contribute to the mistake, and this value is called gradient. Okay? Each trainable parameter is adjusted using the corresponding gradient value. Okay? So how much each parameter should be readjusted given the gradient value is determined by the optimizer. Okay? So we can use something as GD or normal uh, gradient descent or something. And for transformer based model, we use an algo called ADAM for the optimizer in general. Like SGD is one of the option, and I think most of the people are familiar with SGD because all the linear regression or classical LM models we use optimize using SGD mostly. Okay. So let's move on. Okay. I'm moving on to the memory math part, the one that Sir was asking about, right? Okay. So that's why if a model requires 30 GB of memory to do inference, a chip with 24 GB of memory won't be sufficient. So how do we compute first how much memory is required? Okay. The model memory footprint depends upon model as well as workload and different optimization techniques. Okay. Because it's impossible to account for all different technique and workload, so we are only going to look at the formula for the approximate calculation here. So yeah. Okay. So memory needed for a inference. Okay. So inference simply means output, no, not on the training side of thing. Okay. तो आपका अगर number of model parameter is n, just say 13 billion parameter or 10 billion parameter. ठीक है. And for each memory you need a 1 byte, 2 byte or 3 byte of parameter. ठीक है. So what you do, n into m simply. ठीक है. This is the memory required for the parameter itself. ठीक है. Then you also need a memory for the activation function, key value vectors here. Okay. So what you do, you make an approximation that 1.2 is a typical factor which we can use to get the overall memory footprint for the inference side. So basically what it means that just say you are running a deep seek model in your system at a time, okay, your laptop should be able to support this much memory for the inference. अगर आपकी लैपटॉप की RAM is lesser than this, your model won't run here for the inference. Now, when you are hosting the model locally, I'm not talking about a cloud hosted model because they already have that much memory accounted for. Now, for the training part, right? Okay. So there's a one more example, right? A 7 billion parameter model with 2 bytes per parameter will require a 140 GB of memory just for the weight, right? So that's why we say, right, when we are selecting a model for our application, just say all of us are building application, it's always good to use a benchmark of a best model, which is might have a very high parameter number of parameters are high, it supposed to do good. Then find a model which has a low parameter and do well on the selected KPIs which you want to tune for. So take the best model in the market and then pick a smaller model. You can try to fine tune it and try to achieve the performance of the bigger model for your domain use cases. ठीक है, तो दिस इज जस्ट फॉर द इन्फरेंस पार्ट ऑफ थिंग्स, राइट. मेमोरी नीडेड फॉर द ट्रेनिंग. अब ट्रेनिंग के साथ क्या है कि इट्स नॉट जस्ट द इन्फरेंस. You have the model weight, you have the activation, you have the gradient, you have the optimizer state here. So total memory required for the training is much higher in this case. ठीक है, तो then there are also cases like some vanilla SDD optimizer has no state. ठीक है, तो इसमें you don't need a lot of space, but depends on when you're just say choosing Atom for the as an optimizer, you need a lot of space here. ठीक है, now there's an example of actually Atom given here. So just say you are using Atom optimizer in a 13 billion parameter model. Okay, each trainable parameter has three values, one for gradient, one for optimizer state, and if it takes 2 bytes to store each value, so memory required for the gradient and optimizer state will be 13 billion parameter. Each has 3 state, and for each state you need 2 bytes. So total memory that you need here is 78 GB. This is just to store the optimizer and gradient, right? उसके बाद then just say you have only 1 billion instead of 13 billion, right? So your requirement drops from 78 to 6 GB in terms of memory requirement here. Then additional requirement for the parameters. So just say if you go with 13 billion with a double precision, what it means is plus 78 plus 32 GB plus some additional memory required for other like thing compute. अगर आप एक छोटे मॉडल के साथ जा रहे हो, you can simply go with a 6 GB plus 1 billion into 4, which means 4 GB. So you might require 10 to 12 GB of data memory here, which is very doable on a normal laptop, because usually we have a 16 GB of the RAM in a business laptop, right? ठीक है, so we will take this up in the next session because already over the time. बाकी का chapter I will cover in that next session then. Any questions on this?